We've learned to write expressions, and now we know how equations work. Today, we're combining those skills to solve real-world problems. When you read a word problem, it's essentially telling you that two quantities are equal, and one of those quantities is unknown. Your job is to translate that story into a neat equation with an equal sign, and then use the inverse operations to find the missing number. Solving a real-world problem with algebra is a reliable four-step process. First, you clearly define the variable. What are you trying to find? Second, you write the equation that matches the story. Third, you solve the equation using inverse operations. Finally, you check your answer and write it out clearly with the correct units. Follow these steps every time, and you'll get the right answer. Step 1 is defining the variable. You always use a simple let statement to show what the letter represents. If the question asks for the cost of a single candy bar, you might say, let C equal the cost of one candy bar. The variable should always stand for the one piece of information you don't know yet. Step 2 is writing the equation. Look for the total amount, the final cost, the final distance, or the total weight, and place that number by itself on one side of the equal sign. On the other side, you put the expression that represents all the known and unknown parts that add up to that total. The equation must perfectly reflect the relationship described in the problem. To solve the equation, you need inverse operations. These are the key to isolating the variable. Think of them as mathematical opposites that undo each other. If the variable is being added to a number, you use subtraction to cancel it out. If it's being multiplied, you use division. You always apply the inverse operation to the number that is with the variable. Remember the golden rule of algebra, the balance rule. You must treat both sides of the equal sign exactly the same way. If you subtract 15 from the left side, you must subtract 15 from the right side. This ensures the equation remains a true statement, even as you rearrange the numbers to find the solution. Let's try an addition problem. Joe has $15. After getting his allowance, he has a total of $40. How much was his allowance? We let A equal the amount of allowance. His starting money plus his allowance equals the total. 15 plus A equals 40. To solve 15 plus A equals 40, we want to get A by itself. Since 15 is being added to A, we do the inverse. Subtract 15 from both sides. On the left, 15 minus 15 cancels out, leaving A. On the right, 40 minus 15 is 25. The solution is A equals 25. His allowance was $25. Sometimes the problem is just a subtraction sentence. A runner finished a race in R minutes. This time was 8 minutes less than his personal best of 32 minutes. The equation is R equals 32 minus 8. In this case, the unknown, R, is already isolated, so you just do the subtraction. R equals 24 minutes. Here's a subtraction problem where we have to isolate the variable. Maria had $M. After spending $12, she had $25 left. How much did she start with? Her starting money minus what she spent equals what she had left. M minus 12 equals 25. To solve M minus 12 equals 25, we use the inverse of subtraction, which is addition. We add 12 to both sides. The 12s on the left cancel out, leaving M. On the right, 25 plus 12 equals 37, so M equals 37. Maria started with $37. Next, a multiplication problem. Tickets cost $7 each. If the total cost was $49, how many tickets T were bought? The cost per ticket times the number of tickets equals the total cost. 7 times T equals 49, or 7T equals 49. To solve 7T equals 49, we use the inverse of multiplication, division. we divide both sides by 7. On the left, 7 divided by 7 leaves just t. On the right, 49 divided by 7 is 7. The solution is t equals 7. She bought 7 tickets. Finally, a division problem. Alex split his candy C equally among 4 friends. Each friend got 15 pieces. How much candy did he start with? The total candy divided by 4 friends equals 15. The equation is the fraction c over 4 equals 15. To solve the fraction c over 4 equals 15, we use the inverse of division, multiplication. We multiply both sides by 4. On the left, the 4's cancel, leaving c. On the right, 15 times 4 is 60. The solution is c equals 60. He started with 60 pieces of candy. Don't let decimals scare you. The process is exactly the same. If you have the equation 0.5x equals 9.5, you still use the inverse operation, which is division. You divide both sides by 0.5. On the left, you get x. On the right, 9.5 divided by 0.5 equals 19. The solution is x equals 19. We can even use algebraic formulas to solve real-world problems. The formula for the area of a rectangle is length times width equals area. If a field has an area of 45 square meters and a width of 5 meters, what is the length L? We substitute the known values to write the equation L times 5 equals 45. The area equation is 5L equals 45. Since 5 is being multiplied by L, we divide both sides by 5. 45 divided by 5 is 9. The solution is L equals 9. The length of the rectangular field is 9 meters. The final step is crucial, checking and stating the answer. Does 5 times 9 equal 45? Yes. Then you write the final answer as a clear sentence that answers the original question, including the correct units. For example, the length of the field is 9 meters. This is how you show you've truly solved the real-world problem. You've now mastered the 4-step process for solving real-world problems. Always remember to define your variable, write the equation by matching the total, use inverse operations to find the solution, and check your answer to make sure the original statement is true. These skills are the foundation for solving any math problem you encounter.